Hello dear students, you are all welcome to the e-learning class in chemistry. Today we will be discussing the most exciting topic in organic chemistry, that is aldehydes and ketones, the important carbonyl compounds. So, before going to discuss in detail about the aldehydes and ketones, let us have a look into the things to be discussed in today's class, right. So, we will discuss in the beginning introduction, that is definition, then we will do classification of carbonyl compounds, then nomenclature, next structure of carbonyl compounds, and then isomerism. That is, in today's class we will discuss basically about the basics, the fundamentals of carbonyl compounds. So, important thing is, why should we study this chapter? Just because it is given in your syllabus? We have no alternative? We are bound to study this topic? No. Maybe it may be a reason for you, but if you look into its wider applications, such compounds are so widely distributed in nature, and they have such beautiful applications in our day-to-day life. If you know, I am sure you will definitely get some interest to study about these compounds in detail. You know, the carbonyl compounds, I am talking of carbonyl, I am not going into aldehydes and ketones, means the organic compounds containing divalent carbonyl group. The organic compound containing divalent carbonyl group are called as carbonyl compounds. I will discuss in detail. But why these compounds are important? You just see, carbonyl compounds are important organic compounds. They have applications starting from industry up to our home appliances, then in a biological system. You know, acetone. Acetone is a best industrial solvent, widely used in solvents for preparation of drugs, antibiotics, dyes, and many other materials. And in everybody's home, this compound is present, and this is largely used by the ladies, and this compound is known as, this substance is known as nail polish remover. Yes, that is a carbonyl compound. All ladies know what are nail polish remover. Next, if you think of formaldehyde, formaldehyde, it is a 40% aqueous solution. In ethanolic solution, it is called formalin. It is used for as a preservative for dead biological species. If you have visited a biology laboratory, you must have seen the dead species. They have been preserved in different vessels using this solution. Formaldehyde is important component, important ingredient for preparation of many polymers like bakelite. You know bakelite? We use bakelite in making electrical goods, CD, discs, gramophone records. And it is also very important, you know, they are also used as flavoring agent in our food industry. You know, vanillin, vanilla flavor, you must have enjoyed lots of vanilla ice cream, very tasty, very flavor. That is also a compound, you see, that is the aldehyde compound. Cinnamaldehyde, cinnamon flavor, you know, cinnamon, it is just sweet, little bit sweet, and it is a spice. It is present in barks of a plant, and you know, it is popularly known everywhere as garam masala or dalchin. That is an aldehyde compound. Camphor we use while offering diya or doing puja, then we use camphor. Also, in biological system, you know, progesterone. Progesterone is your female sex hormone, that is also carbonyl compound, and testosterone, male sex hormone, testosterone is also carbonyl compounds. So, starting from industry up to biological system, it is present everywhere. That is why it is necessary to know about the carbonyl compounds, right. So, what are carbonyl compounds? Carbonyl compounds are essentially the organic compounds that contain divalent carbonyl group. Divalent carbonyl group. This is a divalent, you know, the valence of a carbon is 4, out of which 2 are permanently engaged with oxygen, 2 are permanently bonded with oxygen, and the remaining 2 valences are free. These 2 valences are free, and any other group can be attached to this free valences. This is called carbonyl. This is called carbonyl. If I add, remember, if I add an alkyl group or any aryl group, means aromatic group, at one side, it will be called as acyl group. It will be called as acyl group, right. If it to one side the alkyl or aryl group is attached, it must be attached, then it is called acyl group, right. Then you just look into these two things. This is a permanent group, and one more valence is left free. If to this acyl group, if I add hydrogen, or if I add another alkyl group, this is aryl or any aryl group, it forms a class of a carbonyl compound. You know, this is called aldehyde, this is called ketone. So, these are class 1 type of carbonyl compounds. If I add OH group to the right side valency, I will get like this. What is it called? It is called acid. If I add any halogen, I will get acid halide. This is your acid halide, right. If I add ammonia amino group, then I will get amide. Clear? If I add OR dash group, then I will get ester. This is ester. This is your amide. If I add OCOR, acyloxy, then I will get, this is called anhydride. This is called anhydride. Acid anhydride. Now you tell me one thing. Are all these compounds called carbonyl compounds? Think up. Can you call all of these compounds carbonyl compounds? Or only these compounds are called as carbonyl compounds? Or only these compounds are called as carbonyl compounds? Yes? Answer. All of these compounds are called as carbonyl compounds. Remember, all these compounds are called as carbonyl compounds. What is the difference between these two? This is called class 1 type of a carbonyl compound. These are called as the class 2 type of a carbonyl compounds. What is the difference? In class 1 type carbonyl compound, you see here it is hydrogen or it may be alkyl or aryl group. This group is permanent. ये तो रहेगा ही रहेगा. But thing is that there is no nucleophile. There is no nucleophile available which can displace these groups from acyl group. दुनिया में ऐसा न्यूक्लियोफाइल पैदा नहीं हुआ है जो इनको यहाँ से निकाल सकते हैं. लेकिन यहाँ देखो, just look here. All of these compounds contain RCO. But thing is that these groups can be easily replaced. Here OH, this is X, this is NH2, this is OR dash, this is OCOR. They can easily be replaced by nucleophiles. So therefore, these are called class 1 carbonyl, these are called class 2 carbonyl, and we will be focused on our discussion on class 1 carbonyls, that is aldehydes and ketones, right. So aldehydes, what are aldehydes? So aldehydes are the class of organic compounds are the carbonyl compounds C double bond O, to which there is a hydrogen atom at one side and there is a alkyl or aryl group at the other side, this one. So, hydrogen must be present at one side and a alkyl or aryl group present on the other side, right. So, this is aldehyde and aldehydes are of two types. If alkyl group is bonded to CO, this is alkyl, this is called aliphatic. If aryl group is bonded, it is called aromatic aldehyde. This is called aromatic. If you take example, this is R, you can, the simplest aldehyde is your formaldehyde. The simplest aliphatic aldehyde is your formaldehyde, next is acetaldehyde, and if you go to higher series, in this way you get different members of aldehyde family, right. And this is aromatic, and we have a well known compound that is your benzaldehyde. We have also many more aromatic aldehydes, we will discuss in detail. Okay. Let us talk about ketones. So, ketones are the divalent carbonyl compounds in which the carbonyl group is bonded to on either side an alkyl group or aryl group, So, ketones can be classified into two categories. One is a simple ketone, another is a mixed ketone. Remember, in ketone, the carbonyl group must be bonded to two dissimilar alkyl or aryl groups. It can be aliphatic or aromatic. If at one side only one aromatic group is or aryl group is bonded, it will be called as aromatic. Okay. So, simple ketone means if the carbonyl group is bonded to two similar groups on either side. For example, acetone, okay, and mixed if they contain dissimilar groups on either side. Means if you have a methyl here, it can be ethyl or any other group. So, this is called mixed ketone, right. Then let us discuss about the nomenclature of aldehydes. You know, aldehydes, they are aldehydes, RCHO, general molecular formula is RCOH, functional group is your COH, this is called formyl, and a suffix is your AL, this is called formyl, and common name, remember, I am going to teach you a trick. Okay? If any functional group that contains carbon like aldehyde, remember this trick, very important. If any functional group that contains carbon like aldehyde, acid chloride, amide, ester, etc., then when hydrogen is bonded, hydrogen can be bonded here. The lowest alkyl group can be your hydrogen. When hydrogen is bonded, we cannot call it hydrogen. In place of hydrogen, we will call it form. Remember this. For methyl, we will call it acid. For ethyl group, we will call it propione. Remember, this is very, very important. C3H7, if it is normal, straight, then we call it butyr. And for branched, it is called isobutyr. And if for C4H9, normal, if straight chain is there, you will call it valer. Let me tell you some example. This is your HCOH. What is it called? For H, we call it form. Remember, this is form. Plus, this is your aldehyde. Plus aldehyde. You combine these. Formaldehyde. If you take CH3COH, what is it called? Acid plus aldehyde. For C2H5, what will you call it, उसको क्या बोलोगे? प्रोपियोन प्लस aldehyde, प्रोपियोनाल्डिहाइड. For a C3H7 COH, what will you call it? Butyraldehyde. And for branched, you will call it isobutyraldehyde. What is IPS name? Just remember, IPS name, here is only one carbon present, only one carbon. So it will be, its suffix will be, how many carbon atoms are there? Only one. So one means it is methane. Remove E. So put Al, methanol. So this will be your, there are two carbon atoms. So it will be ethane. Just remove E and put Al, ethanol. So this will be your, similarly propanol. Okay. This will be your butanol. Right. Now you tell me one thing. If you have a compound like this, what will be its common name and IPS name? It is a common name is, you know, it is common name is benzaldehyde. Benzaldehyde. What will be the IPS name? A special suffix is used here. It is called benzene. It is called benzene carbaldehyde. It is called benzene carbaldehyde. Right? If you have a methyl group here, now you just name it. It is called orthotolulaldehyde. It is called orthotolulaldehyde. Similarly, you can call it 2-methyl benzene carbaldehyde. 2-methyl benzene carbaldehyde. Okay? So, will we do more nomenclatures hereafter? Right? Get ready for doing more nomenclature. So let us do some more nomenclature about aldehydes. Very, very important for examination point of view. Okay. So let us have a quick look into some nomenclatures, some more nomenclature. This is CHO, this is CHO. What is its name? Common name is oxaldehyde. Oxaldehyde. What is IPS name? IPS name 1,2 means ethane. Ethane, E will not be removed. E will not be removed here. Ethane 1,2-diol. Now you tell me what will be the nomenclature of this compound. What will be the nomenclature of this compound? Yes, you can directly just do it. And here this is another compound. What is its name? Acraldehyde common name. What will be IPS name? Yes, come on. 1, 2, 3. What is its IPS name? Prop. 3 carbon atoms. So root word is prop. So there is a double bond here between 2 and 3. So 2En and al. Okay. So in this way you can do the nomenclature. Now you do the nomenclature of this compound. Okay. CHO, CH3. What will be its name? IPS name. This is CHO and this is CH3. And a special name I am giving you, special compound like CH2, CH2, CH2. Here you have a CHO, CHO and a CHO. What will be its name? Since all these groups are terminal functional groups, we cannot include these groups while naming or numbering the chain. So we have to remove these groups, eliminate these groups, then do numbering like this 1, 2, 3. What will be the name? Propane. Special suffix is used here. Propane 1, 2, 3 tricarbaldehyde. Right? Tricarbaldehyde. Similarly, you do this nomenclature CHO, CHO, CH, CHO. I am hopeful you can easily answer the IPS naming of this compound. Next, move to do the nomenclature of ketones. Okay? Ketones, you know, the general molecular formula is RCO, R dash, functional group is CO, means keto or oxo, and the suffix is your ONE, and in common name you see there are two alkyl groups on both sides, either be alkyl or udhar be alkyl. If they are similar, you can call it a dialkyl ketone. If they are dissimilar, you can call it a alkyl ketone, means the alkyl group whose name comes first in alphabetical order will be named first. So, and IPS name is your alkanone, because suffix is ONE and it is added in the last name of alkane by removing E, alkanone. Okay. So, let us have some nomenclature about ketones. The simplest ketone is your CH3CO CH3. It is better known as acetone. This is common name, but its derived name is dimethyl ketone. Dimethyl ketone, right? What will be IPS name? There are three continuous carbon atom, means prop. There are single bonds between them, means AN and a ONE, propanone. Similarly, you can call it, you can also do the nomenclature of this molecule. What will its name? Common name ethyl methyl ketone, because ethyl E comes first. So, ethyl methyl ketone. What will IPS name? Butanone. Butanone. Similarly, you can have a structure like this. Here you have ethyl means diethyl ketone. What will be the IPS name? There are 5 carbon atoms in total, means pent. There are single bonds among them, means AN, and a 1, 2, 3. In the third carbon, it is a carbonyl group, so pentan 3-ONE. Right? So, in this way, you can do the naming. Let us talk about, do some IPS naming of aromatic compounds. What will be its name? It is better known as, common name is acetophenone. It is known as acetophenone, common name. What will be its IPS name? So, this carbonyl comes 1, it is numbered as 1. So, 1, 2 means 1-phenylethanone. Remember this, very important. IUPAC name is 1-phenylethanone, right? Similarly, what will be its name? What will be its name? This is CO, you make it a CO and you make it a CH2. So, again it is 1. Okay? So, there are 3 carbon atoms, means 1-phenyl, this is IPS name, 1-phenyl propan, 1-ONE or propanone. What about this one? Its common name is benzophenone. Benzophenone. What will its IPS name? This is 1 carbon, means diphenylethanone, because only 1 carbon, that is a ketone. So, ketone carbon is numbered as 1. So, its IPS name is diphenylethanone. In this way, a question was asked in a 2012 CHEC annual. Like this, you do the nomenclature CH3, CH, NH2, CH2, CO, CH, this is your Br, this is your CH3. So, in 2012 annual examination, this question was asked to do the nomenclature. So, do the naming. So, from which side you will do the naming? Here you have the, from that side you do the numbering. From that side you do the numbering where the functional group will get lowest number. If you do numbering from this side 1, 2, 3, 4, and from this side 1, 2, 3. So, numbering shall be done from this side 1, 2, 3, 4, 5, 6, right. So, first you do the prefix. Here it is a amino, here it is a bromine, bromo, B, amino, A. So, A comes first, means 5-amino. Substitution is continuing, so there must be hyphen. Next is 2-bromo, right. There are 6 carbon atoms, means hex. There are only single bonds between them, AN, and at third position this is ONE, so 3-ONE. So, this was asked in 2012 annual CHSE examinations. I am sure that you can answer all the kinds of nomenclature that are likely to be asked in the coming examinations. Okay. So, next you see the structure of a carbonyl compounds. We will go into discuss in detail about the structure of a carbonyl compounds. The carbonyl, you know, it is a divalent carbonyl group, it is divalent, and what is its structure means it's a hybridization, bond angle, and how many bonds are present between carbon and oxygen. That is, a double bond is present. If a double bond is present, for what reason, what type of bonding takes place. Okay. So, we will discuss it in later. Let us discuss about the structure of a carbonyl compound. You know, the carbonyl group is the only and main functional group of aldehydes and ketones, because it is the reaction place. All types of reactions take place at this center, at this carbonyl carbon center. Therefore, it is necessary to know its structure, its geometry, and the nature of a bonding, so that the properties, chemical properties can be well understood, right. So, in a carbonyl compound, you know, this is the general structure of a carbonyl. You know, carbon atomic number is 6. Its excited state configuration is 1s2, 2s1, 2px1, 2py1, and 2pz1. That means it undergoes sp2 hybridization. sp2 hybridization. It intermixes the half filled 2s, 2px and 2py orbital and produces 3 sp2 hybrid orbitals, right, and each hybrid orbital contains 1 electron and are arranged in this way in a trigonal planar manner. This is a sp2 hybrid orbital and this is a sp2 hybrid orbital, this is a, and the 2pz orbital is remaining perpendicular to this plane. This is sp2, 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 right. What about oxygen? Atomic number is 8. Its configuration is 1s2, 2s2, 2px2, 2py1 and 2pz1. It also undergoes sp2 hybridization, producing 3 sp2 hybrid orbitals. Here you see the 2 atomic orbitals are fully filled. So, the 3 hybrid orbitals out of 3 sp2 hybrid orbitals, sp2, 2 are fully filled and 1 is half filled, right. 1 is half filled. This is sp2 half filled hybrid orbital. This is sp2 half filled hybrid orbital of a oxygen atom overlap with the sp2 hybrid orbital of a carbon atom and form a sigma bond. उसकी sp2 hybrid orbital और उसकी sp2 hybrid orbital along the axis, they overlap and make a sigma bond, right. And the 2 other sp2 hybrid orbitals, you see, they contain lone pair of electrons. So, this is lone pair or non-bonding electrons, but they lie on same plane. Here it has one unhybridized 2pz orbital that remains perpendicular to this plane. This is the 2pz orbital of a oxygen atom. So, the 2pz orbital of a carbon and a 2pz orbital of a oxygen both are half filled. Now, they overlap above and below the internuclear axis and form a pi bond. These remaining sp2 hybrid orbitals of a carbon, they make sigma bonds with the other 2 groups, maybe with the hydrogen or alkyl groups or aryl groups. So, what is the structure? You see, so this is C, a double bond is formed between carbon and oxygen. This is through sp2 overlapping, and this is through pz overlapping, and oxygen contains 2 lone pair of electrons, and this carbon again forms 2 sigma bonds through sp2. The sp2 hybrid orbital of a carbon, maybe in case of a aldehyde, it is a hydrogen 1s orbital of hydrogen, and in case of a ketone, you may have sp3 or sp2 hybrid orbital of a. In case of a alkyl group, it is sp3 hybrid orbital of a carbon with the sp2 hybrid orbital of a carbon, they make sigma bond. In case of aromatic group, it is sp2 hybridorbital of a aromatic group makes sigma bond with the sp2 hybridorbital of a carbon atom. So, there are 2 sigma bonds. So, that means the shape is your trigonal planar. It is called trigonal planar, right? And the bond angle, about bond angle, you see C double bond O. What about bond angle? Bond angle is supposed to be 120 degree. Suppose this is bond angle X, this is bond angle X, this is bond angle Y. But all the bond angles are not equal here because multiple bond is here is a double bond means there are 4 electron pairs, 2 electron pairs, 4 electrons. They cause strong repulsion on these bond pairs. So, that is the bond angle of X equal to this is Y. So, make it Z. So, X equal to Y and they are greater than Z. So, the bond angle of a Z is less than 120 degree and it is nearly about 117 degree aspas, and X equal to Y, these 2 angles are more than 120 degree. Trigonal planar, carbon is sp2 hybridized. This is very, very important, and it is polar because oxygen is more electronegative, and the electron pair you see the pi electron and sigma electrons, they are always displaced towards oxygen because it is more electronegative. So, that is why it gets partial negative charge, this gets partial positive charge, and carbon becomes electrophilic center. So, it is a electrophilic center because it is electron deficient, right. Next, we will discuss about isomerism shown by aldehydes and ketones. There are 5 types of isomerism depending upon their structure exhibited by aldehydes and ketones, like chain isomerism, position isomerism, functional isomerism, metamerism and tautomerism. You know isomers? Same molecular formula represents different structural formula or different structures having different properties. Each structure is called as an isomer. And here it is a chain isomerism means मैंने कहा था जैसा नाम ऐसा काम. Chain isomerism means the different aldehydes or ketones, they have different nature of a carbon chain. Important thing is for aldehyde to exhibit chain isomerism, aldehyde को chain isomerism exhibit करने के लिए कम से कम 4 carbon atoms चाहिए including its functional group. For ketone it needs 5 or more carbon atoms. If ketone contains 5 or more carbon atoms, then it will show your chain isomerism. Like, let us have a look. So, aldehydes containing 4 carbon atoms, at least 4 carbon atoms show chain isomerism like this. You have C, 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 this is your CHO. So, this is called N-butyl, or we can call it butanol, right. We can have a branch here, we can make a branch. There are 4 carbon atoms. So, we can call it 1, 2, 3. So, 2-methyl propanol. So, that means butanol and 2-methyl propanol are called as chain isomers, right. Similarly, you can also do the different chain isomers taking 5 carbon atoms. So, there will be 4 chain isomers if you take 5 carbon atoms in the aldehyde. Similarly, in case of a ketone, you need 5 carbon atoms, at least 5 carbon atoms like this. You see, you need 5 carbon atoms, means here. Then you can have a ketone like this. Similar to, you can make a branching on this chain. So, for ketone, you need 5 carbon atoms to show or to see or to exhibit chain isomerism, and in case of aldehyde, they need 4 carbon atoms at least. Next is position isomerism, means you can have different positions of the functional groups in the molecules. Let me tell one thing very clearly, aldehydes do not show any position isomerism. Aldehydes do not show any position isomerism. Let me give one example here. Higher ketones only show, higher ketones only, that means ketones containing more 5 or more number of carbon atoms, जिस कीटोन के पास 5 और उससे कार्बन आटम्स है वो पोजीशन आइसोमरिज्म दिखा सकते हैं, लेकिन आल्डिहाइड कभी पोजीशन आइसोमरिज्म एग्जिबिट नहीं करते हैं, क्योंकि उनका जो पोजीशन आइसोमर्स है उनका वही होते हैं चेन आइसोमर्स. देखो, सपोज दिस इज योर aldehyde, right? This is called butanol. If you think that this is main functional group and it is present at terminal position and you can bring it to middle carbon, okay, you can bring it to middle carbon and you can say this is its position is changed from terminal to middle. Why it cannot be position isomer? No, no, it is not possible, because for aldehyde कहते हैं ना, जहां मैं खड़ा होता हूं वहीं से लाइन शुरू होती है, तो ये wherever it is attached, numbering starts from here. Again you see it's a position isomer, it's a, you just see it's a chain isomer. What was it's a chain isomer? Was like this, and what is this? आप जिसको उसका पोजीशन आइसोमर कहते हैं वो कुछ नहीं, उसका ही सिर्फ चेन आइसोमर है. सो aldehyde do not show chain isomerism, aldehydes do not show position isomerism at all, right? Okay. Dear students, you have learned what type of isomerisms are exhibited by aldehydes and ketones. One thing, remember, the position isomerism is not shown by aliphatic aldehydes, but aromatic aldehydes can show position isomerism. Aromatic aldehydes can exhibit position isomerism if it is substituted. For example, if you have like this CHO and you bring here methyl group, you call it orthotolulaldehyde, right? So similarly, I can change the position of this group or this group with respect to each other. I can have a different position like here CHO and you have methyl group here. So this is metatolulaldehyde. So orthotolulaldehyde and metatolulaldehyde are position isomers. पोजिशन को बस चेंज कर दिया, ऑर्थो से लाके मेटा में रख दिया. और कहाँ पे मैं रख सकता हूँ? पारा पे भी रख सकता हूँ. CHO, I can place the methyl group at para position. So this is paratolulaldehyde. So aromatic aldehydes can exhibit position isomerism but not aliphatic, because the position isomer of aliphatic aldehydes are nothing but they are chain isomers. Next is functional isomerism. Means the same molecular formula represents different structures, they differ from each other in the nature of a functional group. Functional group अलग होंगे. देखो, very important, the functional isomer of aldehyde and ketone. Aldehydes and ketones containing at least 3 carbon atoms are functional isomers of each other. Not only this, there are many compounds like cyclic oxides, unsaturated alcohols, unsaturated ethers, cyclic alcohols, they are also functional isomers of aldehydes and ketones. Let's have the example. Once again I am repeating, aldehydes and ketones with cyclic oxides, unsaturated alcohols, unsaturated ethers and cyclic alcohols, they are all functional isomers of each other. Let's have an example. So C3H6O, this was asked in some entrance examination. Like I can have a compound like CH3, CH2, CHO, okay. Propionaldehyde number 1. I can have acetone, this is aldehyde and it is a functional isomer is a ketone. Next I can write CH3, this is enol, this is enol, and a fourth one I can have oxytane, C3H6O, cyclic ether. Also I can have like this oxygen. This is CH, U3, again it is C3H6O. Another one I can have like this. Also I can have another compound like this. There are 7 functional isomers: aldehyde, ketone, enol, cyclic ether, this is the epoxy compound, this is cyclic alcohol, and this is the unsaturated ether. They are all functional isomers of each other. But thing is, important thing is, aldehyde and ketones, aldehydes containing at least 3 carbon atoms must be having functional isomer with its ketone, right. So, next is your metamerism. Metamerism means same molecular formula represents different structural formula which differ from each other in the nature of alkyl group around polyvalent functional group. Functional group वही की वही रहेगी, लेकिन उसके जो दोनों तरफ से, दोनों साइड से जो alkyl group उसमें अलग होना चाहिए, ठीक है. So this isomerism is only shown by ketones, not aldehydes. Metamerism is not shown by aldehydes but only shown by ketones. Okay. Just have a look. So here you have 5 carbon. This is your, what is it called? Pentan 2ONE. I can write the, you see here it is the functional group. There is only 1 carbon at one side and there are 3 carbon atoms on the other side. I have distributed the 4 carbon atoms in this way, that 1 carbon atom one side and 3 at the other side. Similarly, I can also distribute in this way. You have 2 out of 4, I can place 2 on left hand side and 2 on the right hand side, right. So nature of alkyl group is different here. So that is pentan 2-ONE and pentan 3-ONE. This is pentan 3-ONE. They are called as metamers of a ketone. And these 2 metamers, they have also another relation. Remember, what is that relation? Yes, remember, they are also their position isomers. So they are also position isomers. That means the metamers of ketones are also their position isomers. Very important. Remember this one. Okay. Next is tautomerism. Very, very important. Tautomerism means aldehydes and ketones, they remain in equilibrium position, they remain in equilibrium state in solution with their another form. If one is called keto form, another is called enol. That means the molecule exists in 2 structures which remain in equilibrium position. That is called tautomerism. Means keto, this is called keto enol tautomerism. If one structure is keto, another is enol. So the ketones or aldehydes or carbonyl compounds, means aldehyde or ketones containing at least 1 alpha hydrogen atom. जिस aldehyde और ketone के पास कम से कम एक ही alpha hydrogen atom हो, it will only exhibit or it will only form its enolic structure and remain in equilibrium with that structure. बस देखो example, if I take acetaldehyde, ध्यान से देखो इधर acetaldehyde. So this is alpha carbon. So here there are 3 alpha hydrogen atoms. I just mentioned 1 alpha hydrogen atom. So this molecule remains in equilibrium. If you take acetaldehyde, all molecules will not exist in this form. Some molecule will remain in another structural form. What is that structural form? Now you take this alpha hydrogen away from here. You take it out. I am just telling you the technique how to write the enol form. Take this hydrogen, alpha hydrogen here, and break this bond, means this bond breaks here. ये bond यहाँ पे टूट गया. So यहाँ से डबल बॉन्ड बना दो. इसी हाइड्रोजन को लेके ये इसी ऑक्सीजन के पास लगा दो और ये जो डबल बॉन्ड उसको तोड़ दो. तो क्या बनेगा यहाँ पे CH2 डबल बॉन्ड C, यहाँ पे सिंगल बॉन्ड हो जाएगा, O इसके साथ H लग जाएगा और यहाँ पे H आ गया. इसको कहते हैं एनॉल. देखो इनी Ene plus OH means is all, means enol. How you convert enol to keto? So this is keto form, this is keto form. So this is enol form, this is keto form, this is enol form. Remember, keto can be converted to enol. How? Take out this alpha hydrogen, place it with or put it with oxygen, break this double bond and make this double bond here, right? रिवर्स वे, ये अगर तुमको दे दिया गया है एनॉल, पूछा जाएगा कि राइट इट्स कीटो फॉर्म, कैसे लिखोगे? यहाँ से H को निकाल दो और ये जो कार्बन के साथ जो डबल बॉन्ड है उसी कार्बन के पास, ये कार्बन जिस कार्बन के साथ बॉन्ड किया है उसी कार्बन को ये हाइड्रोजन दे दो, मतलब CH3 और यहाँ पे डबल बॉन्ड कर दो, ये डबल बॉन्ड को तोड़ दो, ठीक है? देखो एसीटोन, similarly you can have also acetone can exist in a tautomeric form. This is alpha, this is also alpha. You have 6 alpha hydrogen atoms, but we need only 1 alpha hydrogen atom. That means here you make a double bond here, C, you make OH here, CH3. So this is enol. Similarly, you can have also CO, CH2, CO, CH3. Now tell me, which alpha hydrogen will form enolic structure? Here it is alpha, this is alpha, this is alpha. Remember, only active hydrogen, because this CO group you see, this is less active, this is less active, this is more active because it is bonded with 2 electron withdrawing groups, minus I group, this is minus I group, minus I group. So they withdraw the electrons from this bond. So this hydrogen is active. So this hydrogen is active. That means only this hydrogen will tautomerize. So in this way, you can make the tautomeric structure like CH3, C, you make OH here, right? Make a double bond here, C, then CH, then you have CO, CH3. You can also do the same thing with this keto group. Thing is that which structure is more stable? Remember, in most of the cases, the keto structures are more stable than enol structure, because in enol you see there is a double bond, it is highly unstable, more reactive. There is also alcoholic group. 2 more reactive group अगर इसी कंपाउंड में होंगे, किसी भी कंपाउंड में अगर दोनों रिएक्टिव ग्रुप होंगे तो वो कभी स्टेबल नहीं हो सकता है ना? सो देयरफॉर कीटो फॉर्म्स आर मोर स्टेबल. इफ यू टेक एसीटोन, 99.9% acetone exists in ketonic form in equilibrium state in a solution, but it is less than 0.01%. Now you can imagine the enol form is unstable, but not in all cases it is unstable. If you take very interesting example, if you take phenol, this is phenol, right? It can also have ketonic, it can have also tautomeric form. That means enol can exist with its ketonic form. What will its ketonic form? Tell, बोलो भाई, किस इसका ketonic form क्या होगा? ये मैंने क्या बताया था? O के पास जो H है यहाँ ले आओ, यहाँ भी एक H है पहले से, यहाँ पे एक H है पहले से, अभी H आ गया यहाँ पे, ठीक है? ये बॉन्ड को तोड़ दो, यहाँ डबल बॉन्ड बना लो, ठीक है? बस हो गया, ये दोनों बॉन्ड यहाँ पे रह गया. सो इसका कीटो फॉर्म. सो दिस इज कीटो, दिस इज एनोल. सो व्हाई इट इज कॉल्ड फेनॉल? डू यू नो व्हाई इट इज कॉल्ड फेनॉल? बिकॉज इट कंटेन्स ए फिनाइल. It contains a phenyl group, means a benzene group. It shows the properties of a benzene and enol. This is called enol. Enol. This is called enol. Phenyl plus enol equal to phenol. Means it shows the properties of both a benzene phenyl group and also enol group. That is why it reacts with the ferric chloride solution. All enolic system, they react with the ferric chloride and produces violet color. That is why phenol, it is a characteristic test of phenol, reacts with the ferric chloride, produces a violet color, right? But thing is that here phenol is more stable. It cannot exist in its keto form. Why? Here it is a keto form. यहाँ पे मॉलिक्यूल कीटो फॉर्म में एग्जिस्ट नहीं कर सकता है. it always exists in enolgic form, because enolgic form is more stable. It gets stability through two things. Remember, it gets stability through two things. One is it becomes aromatic, gets stability through aromaticity. Number two, gets stability through your resonance or called mesomeric effect. Resonance or mesomeric effect. You must have read it in phenol. So it has दो स्टेबिलिटी, इसके पास दो स्टेबिलिटी, और यहाँ क्या हो गया, देखो ये डबल बॉन्ड रिंग से बाहर चला गया. यू हैव ओनली टू डबल बॉन्ड्स इन कंजुगेशन. उसको जो भी थोड़ा बहुत स्टेबिलिटी मिल रहा है वो सिर्फ और सिर्फ थोड़ा सा रेजोनेंस की वजह से मिल रहा है. लेकिन इसका दूसरा बात है कि इट बिकम्स एंटी एरोमेटिक. ये अगर कीटो फॉर्म एग्जिस्ट करेगा तो वो एंटी एरोमेटिक ही बन जाएगा, और एंटी एरोमेटिक यू नो anti-aromatics are highly unstable, so phenol does not exist in keto form, right. So this is very important, why most of the keto compounds exist in ketonic form, but here it exists in enolic form. So I am giving you some examples, you just work it out. I am giving you some examples. Now you tell me what will be their enol form, and I will give you some enol form. You just tell me what will be their corresponding keto form. I am giving you this ketone. This is one. Write its enolic form. If I give you like this one, write its enol form. Enol form is stable where? Where it forms hydrogen bonding or gets stabilization through resonance or aromaticity. What will be its? So you have H here, so its enol form will be like this, and here it is active hydrogen, so its enol form will be like this. Okay. So I think with this class I am hopeful that whatever questions are likely to come from this fundamental portions of aldehyde ketone, you will definitely be able to answer all the questions. So thank you for attending the class till the end. Thank you all.